Hi everyone. So this video will actually be about mass fraction. So let's start. So first of all, what you should know that symbol for mass fraction is small letter w. Let's go with a simple task, food. So what do we have here? We have a chocolate with some kind of nuts, and let's say the all amount of all of these together is 100 grams. Then, how this chocolate is made of, let's say, just two ingredients in our case now, so chocolate and nuts. And let's say that we have chocolate, that the mass of the chocolate will be 80 grams, and nuts approximately 20 grams. Why this is on this slide? Because we want to demonstrate mass fraction first using food, later using chemistry. Meaning, why we need all these data? Let's say hypothetically, now you have this data and you want to calculate the actually how much is the mass fraction of these nuts inside of the chocolate product in the end. Meaning this chocolate on the left side, nuts on the right side. This is like chemical equation in chemistry. Meaning how we can calculate that. You already know that the finished product, let's say call it mixture, it's 100 grams. You know that nuts, in this case, you have 20 grams and chocolate is 80. How we can calculate that? Regarding mass fraction, we use a formula, meaning that the substance that you want to find out, in our case nuts, we will use the mass of the thing that we want to find out, meaning on the top you'll have mass of nuts and you need to divide it with the total mass of the whole mixture, in our case chocolate with nuts. And of course, because we're talking about mass fraction, you need to multiply with 100%. In our case, so nuts 20 grams divided by chocolate with nuts 100 grams. So 20 divided by 100 is 0.2 times 100% give us 20%. So in this case, mass fraction of nuts will be 20% in this chocolate with nuts. While my next question for you will be, how much is then percentage or mass fraction of chocolate in this chocolate with nuts? So easy step will be just 100% is the total, like the maximum, minus 20% that you have nuts, meaning that actually 80% of kind of pure chocolate you have in this product. Math is not always so simple, meaning regarding this mass fraction, in most common products, you will find, let's say, percentage, and then you need to find out actually the mass of the thing that you have in that product. Let's say again with chocolate. So let's say that this product, the amount of all this mixture, let's say this chocolate, is 150 grams. And the next data that you have is that specific nuts inside of this chocolate, hazelnut, is 34%. So the data you have is the mass of the mixture, 150 grams, and the percentage or mass fraction of the hazelnut, which is 34%. If you notice, I divided with 100, which is 0.34, because we will need to use it in calculations. But before you use the number in calculation, it's much easier immediately divide with 100. So what we want to find out? We want to find out actually what is the mass of hazelnut in this Lindt chocolate. So again, mass fraction, small w, what we need to find out, hazelnut in the mixture. So meaning we need the mass of these nuts and divided by mass of the mixture. But the problem is we have mass of the mixture, we have mass fraction, and we don't know the mass of the hazelnut. But in this case, you know two things and one you need to calculate. Only thing that it's kind of a problem, actually it's not if you know how to do it, is rearrange the formula. So we need to calculate the mass of the hazelnut, meaning that how we will rearrange the formula. Mass of the hazelnut in this case will be equal to the mass of the mixture times with the mass fraction. So this is rearrangement of the formula. When you're done with that, you're putting numbers. So mass of the mixture 150 grams, 150 grams times mass fraction 0.34, meaning that mass of the hazelnut is actually 51 gram. If you have 51 gram of these nuts in this chocolate, so how much is actually everything else in the chocolate? You know that the mass of the mixture is 150 grams. Now you know that mass of the hazelnut is 51 gram. So meaning that everything else inside of the chocolate will be approximately 99 grams chocolate and every other stuff that this chocolate is made of. Now, when we are done with chocolates, and let's actually combine this mass fraction in chemistry. So let's say that you have carbon dioxide and you want to calculate the mass fraction of oxygen in this carbon dioxide. So first of all, we already know that oxygen in carbon dioxide, you have 2 atoms of oxygen. And we already know when we want to do mass fraction that this mass fraction you put on the top something that you want to find out, mass of something that you want to find out, and on the bottom mass of the mixture, and everything you need to times with 100%. The thing is, we don't have mass of oxygen. I mean, we still don't have. We don't have mass of carbon dioxide. But what we can do, we can find out the relative atomic mass of carbon and relative atomic mass of oxygen. Where? In periodic table. So for carbon is 12.011, depends on periodic table, and for oxygen is 15.999. Again, depends on periodic table. Next step. What's next? By now, we should know that relative atomic mass is actually equal to the mass of that chemical element divided by Dalton. We should know by now, when you rearrange the formula, that actually mass of that element then will be equal to relative atomic mass times Dalton. In our case, mass of carbon is 12.011 times Dalton, meaning relative atomic mass of carbon is 12.011 times Dalton. So in this case, in this formula, instead of mass of O2, actually you can just put AR times Dalton, meaning for oxygen will be 15.999 times Dalton. The next thing is MR, or relative molecular mass, is also equal mass of the molecule or compound divided by Dalton, or mass of the molecule or compound is equal relative molecular mass times Dalton. Again, rearrangement of the formula. If you notice, they're the same. Just here is for atoms, here for molecules. We can actually calculate MR. I already explained that in video before, but what you need to consider chemical elements you have and the number of atoms you have. So here we already have MR for carbon dioxide. So you have 1 carbon, so 1 AR of carbon, 2 times AR of oxygen, because 2 atoms of oxygen. When you multiply and then add all together, the result is 44.009 Dalton. Again, in this mass fraction formula, instead of mass of carbon dioxide, now you have it, or how you will do it, you will put 44.009 dA, meaning now this mass for oxygen, if you notice, I put here 2 times AR of O times Dalton. And below is MrCO2 times Dalton. So first I will explain why below is MrCO2 times Dalton. We already mentioned that mass of the molecule is equal to the MR times dA, or Dalton. Why on the top we have 2 times AR of O times Dalton? Because in our molecule we have 2 atoms of oxygen. So it's not correct just put 1. So you need to consider both of them. Why cross this dA up and down? Because they are equal. So this unit is equal, and we will not need it because in the end we are getting percentage, so this is why it's crossed. After that, instead of these ARs, we're actually an MR, we are putting numbers. So for oxygen, 2 times 15.999, because we had 2 atoms in this molecule, divided by 44.009. This is the relative molecular mass that we calculated for this molecule, times 100%. In the end, when you divide, first multiply for oxygen, then divide the numbers, you get 0.7271 times 100, meaning that mass fraction of oxygen in carbon dioxide will be 72.71%. This is for oxygen. You know that this molecule is made of two elements, carbon and oxygen. If you know the mass fraction of carbon, or in this case you know only for oxygen, which is 72.71%, will you be able to calculate for carbon, like some easy step? Yes, you will, meaning that percentage, the maximum percentage in this case is 100%. And you know, if you know that, now you know that oxygen is 72.71. So how you can calculate for carbon? So 100% minus 72.71 gives you actually percentage for carbon. This will be your task to calculate.
So AMU or dA, Dalton, they are basically the same thing, meaning atomic mass unit. 1 Dalton is equal to 1.66 times 10 to the power minus 27 kilogram, or we can also say 1.66 times 10 to the power minus 24 grams. For example, we already know that AR is equal mass divided by Dalton, or in second words, mass is actually AR times Dalton, when you want to, of course, calculate. Then, if we are talking about relative molecular mass, then mass is this one will be equal mass divided by Dalton. Second words, mass is equal to mR times Dalton. For example, if you have a relative atomic mass of carbon, which is 12.011, how you can calculate the mass of one carbon atom? So what you need to do, use this formula. So AR times Dalton. In our case, AR is 12.011 times dA or times Dalton. And task is solved. For relative molecular mass, it will be similar, just you will need to combine different relative atomic masses of different chemical elements. One really important thing to mention is that dA, AMU, and U are different symbols for used for the same thing, meaning they're all representing atomic mass unit. AMU is the old one, but is still used today, just that you're aware if you see all three of these that they are meaning the same, or they're all the same number, 1.66 times 10 to the power minus 27 kilogram. Now, in previous task, we have relative molecular mass of carbon dioxide, which we calculate, and it was 44.009. If you want to calculate the mass of the relative of this carbon dioxide, how we can do that? We need to use this mR times Dalton. So in our case, this will be 44.009 Daltons. Or, of course, you can represent it using AMU or U. How we can actually get mass of the atom or molecule in grams? So, for example, mass of carbon we already solved in the previous task, and it was 12.011 U or AMU or Dalton. And we already know that Dalton is equal to these two numbers, depends, do you want in grams or kilograms. So what you need to do, you need to multiply this number with 1.66. The number that you get will be 19.44 times 10 to the power minus 27 kilogram. And this is basically solved task. If you want for a molecule, in previous task we calculated the mass of the molecule was 44.009 U or dA, Dalton or AMU. So again, what you need to do, you need to multiply that number with 1.66. The number that you get will be 73.05, and you need to multiply it with 10 to the power minus 27 kilogram. And again, this task is solved.
Then, let's say that you have task that you need to calculate something. What you need to calculate? So, you need to calculate the mass fraction of, let's say, nitrogen and oxygen in a molecule called nitrogen dioxide. The formula of nitrogen dioxide is NO2. And what else do you have in the task? In the task, you have that the atomic mass of nitrogen is 14.007 AMU, and atomic mass of oxygen is 31.998 AMU. So that you can calculate the mass fraction of nitrogen and oxygen, you also need to have the mass of the whole molecule. How you can calculate that? You have both masses of nitrogen and oxygen, so mass of the molecule should be actually, when you add them all together, it should be, it is. In our case, when you add them all together, meaning for nitrogen and oxygen, will be 46.005 AMU. The next step, let's start with oxygen. So mass of the oxygen, mass fraction for the oxygen in this molecule will be mass of oxygen divided by mass of the mixture of N or nitrogen dioxide, NO2, times 100%. So mass of the oxygen was 31.998 AMU, and the mass of the NO2 or the mixture compound, was 46.005 AMU times 100%. The number that you will get is 69.55%. So this is mass fraction of oxygen. Again, this molecule is made of two chemical elements, oxygen and nitrogen. For oxygen, we already have mass fraction, and we know that percentage maximum is 100. So if you need to, and in this task you need to calculate the mass fraction of nitrogen also, the simple way how you can do it, 100% minus 69.55, and the number that you get is mass fraction of nitrogen. In this case is 30.45%. And this is solve task. I hope this was helpful, and good luck everyone.